Hello and welcome to the Opto 22 webinar, Energy Monitoring and the OptoEMU Sensor. My name is Arun Sinha, and I will have Ben Orchard join me through the Q&A portion. So with that, I'm going to go ahead and get started with our presentation this morning, Energy Monitoring and the OptoEMU Sensor. We will start with a question. I want to set the stage a little bit for why Opto 22 designed this product. What need were we trying to address? And that fundamental question is why consider energy monitoring? And the thing I want to pose to you, or the situation I want to bring up, is it's interesting how a typical manager, be it in a industrial facility or a commercial facility, it doesn't matter, how that person doesn't approve a major expenditure without a detailed accounting of where the money is spent. Yet the common situation today is that energy is not accounted for in that same detailed way. It's kind of an overhead. We don't really look at energy, we just take it as a given, and we operate our building or our facility or our factory without an accounting of energy. That is the fundamental question that this product was born out of, that we're hoping to address with the OptoEMU sensor. Now, the answer to that question, we've done a lot of studying of this situation with customers over the past couple of years, and there's a lot of answers we've gotten as to why energy is not accounted for, and there's a list of them there. I think things are changing. Energy is kind of the last frontier on a way for a operation to lower costs. It typically hasn't been looked at, and people are starting to look at it. And also things are changing with relation to the build out of the smart grid and some of the programs that utilities are offering their clients. So I think accountability is the key reason why people don't look at energy. There isn't any accountability typically. The situation is, let's say for the industrial example here, you have let's say IT equipment and computers, you have plant equipment that require operations and maintenance, you have personnel, labor costs, and you have raw materials. And those things typically make up your cost of production. But what we're seeing today most of the time, there are exceptions, is that energy is not in that cost of production. It's not in that bill of materials for a process or a product or a machine or an operation. So that's where things are today. And basically what typically happens, and it happened here at Opto 22 up until about 3 years ago, is that we run our factory here, we run our operations, and the electricity bill went to somebody in accounting upstairs who never has been down to the factory, and there's really no correlation between the two. So she paid the energy bill, we ran our factory the way we ran it, and it wasn't a correlation. That's a typical situation of how things are today, and that presents an opportunity, and that's where the product was born out of. And the opportunity is energy awareness. For those of you on the call that are kind of in the business of instrumentations, controls, automation, we measure everything. I mean, you name the type of signal, process, device, machine, instrument, and we can measure it. But that's typically not done for energy or power. It may be for power quality or to look at, phase imbalances or harmonics, but not from a cost perspective. So the opportunity for us, whether you're at a manufacturing or process plant, or whether you're a machine builder, or whether you're a system integrator, the opportunity is energy awareness. So that lack of energy visibility is the current problem. The implication is typically higher than necessary operational costs. So what we're trying to address here is the ability, like we do for other process variables, to do so for energy, and that is acquire data and understand. Once that's done, it's amazing, and we've seen this, how many assumptions can be eliminated, trouble spots, machines that are operating out of spec, and a lot of the time a strategy to correct those situations can be simple procedural or behavioral changes. We're not, in our industry, we have the tendency to jump to control right away. Let's control something. Well, 90% of the time we've seen that tremendous savings can be realized by changing the way a process or a machine or a building operates. So that is the potential reality that can be realized with energy monitoring. We can start to look at a building or a process or even down to a machine and look at the energy, associate that with the cost of running that machine, process, or building, and start to find ways to save. The first step, of course, you can only effectively manage what you can ably measure. So that's segues into the OptoEMU system. That's what this product is all about. Our goal, and hopefully we've accomplished that, is take energy monitoring and make it simple. Make a very easy to use device, something that can be understood, deployed, and utilized in a very simple manner. There are a lot of BAS systems out there that cost hundreds of thousands, if not millions of dollars, and what we hope to address is from the small to medium-sized businesses up to larger facilities, since this is expandable and scalable, we want to give a low barrier to entry as far as getting some energy data and making some sense out of it. Okay, so what is the OptoEMU system? It is a device. We're calling it an appliance, and you'll see why I call it that. But it's a device to connect to and acquire energy usage data. So basically, as you know, we're primarily a hardware company, and we're making a piece of hardware that can connect either directly to a machine or device or to a utility meter and gather that energy usage data, digitize it, and then what we do with it from there is it can be distributed to various applications, which we'll talk about. So basically, want to give either a user or a machine builder the opportunity to visualize their energy data. There's two main components to the OptoEMU system. The lower one, which is the OptoEMU server, the second bullet there, is a product we'll be releasing next year. But the product we've released today is the OptoEMU sensor, and I'll tell you how these kind of fit together or stand alone. So the OptoEMU sensor is the device that can be connected to a utility meter or to a branch circuit, to a sub-panel, to a, let's call it a sub-metering device such as a power quality analyzer, or directly to a machine, a compressor, a motor, chiller, air handlers, conveyors, anything that's a consumer of electricity. So this basically, the OptoEMU sensor connects to the energy consuming device or building and takes that data and puts it into software applications. The server is a product that we'll be coming out with next year that sort of has two purposes. Number one is if you had a distributed system of sensors, you could consolidate that data into the server, and that data gets put into MySQL tables, or I should say SQL tables, and that the other usage for it is if you were a machine, if you're an OEM or a system integrator or software developer, you could build an application upon the OptoEMU server and get that data out of SQL into your application. So let's talk about the OptoEMU sensor first. There's a picture of it. It's basically a fixed device. It takes inputs only, and it can be networked like our standard product on a wired or wireless network. If you had several of these devices distributed throughout a plant, the inputs to the device, number one, if you were to connect directly to power wires, we accept CT inputs, so current transformers. We can do either one 3-phase input or 3 single-phase inputs. We can also talk serial or Ethernet from this device, like our standard product, in the event that we wanted to share data with a BAS system, with a sub-meter, with a power quality analyzer. We also accept pulse inputs. So many of the smart meters that the utilities have installed or are going to be installing into commercial and industrial buildings have a pulse output that represents your kilowatt hours, and so we can accept those as well. We say it's pre-programmed as well as programmable, and I'll dive into that more. Basically, the goal of this product is to have it be a turnkey off-the-shelf product that can be installed and put into operation and the data available immediately. So there's configuration to be done, but no programming per se. We say it's programmable because underneath the hood is a PAC control strategy for those of you that are familiar with our standard products. So if you are a system integrator, you can get underneath there and do other things with the product, and I'll get into that a little bit more. So that's the piece of hardware. That's how we connect to devices and buildings. What we do with that data is we automatically push that data to cloud applications. Software as a service is the terminology that's commonly used. We have, out of the box, 2 software as a service packages that we can send data immediately to. One is Google Power Meter. I don't know if you're familiar with that, but I'll show you that briefly later. But that is a free device or free software as a service that all you need is a Gmail account. So we can push the data into Google Power Meter immediately. The other is a company in Canada that we've partnered with and developed the application program interface, or API, to and embedded it into the device. Pulse Energy has a software for energy monitoring that takes it one step further. This package is a little more comprehensive. It is a pay-for-service, but you can do several things with that software package, getting into analytics as well as occupant engagement screens, dashboards, etc. When we released the OptoEMU server, if you had a distributed environment and you wanted to take several OptoEMU sensors and bring them into the server to put their data into SQL database, you will be able to do that as well. Also, if you are an application developer and you wanted to develop your own either cloud-based software or standard PC-based software that runs on a local server, you could use that to develop your applications as well. And so that device could either serve the consolidated data to the cloud or to your application of choice. So that's a kind of a broad brush overview. I want to also mention that because the OptoEMU sensor is built on standard Opto 22 technology, we of course can share data as well with, let's call them our plant floor applications like Pack Project, Wonderware, Intolution, business apps, etc. When I think of the two situations kind of within the four walls of a factory or facility and in the cloud, I think of the separate types of users that would be accessing energy information. So for people who work in process or manufacturing, kind of plant floor people, plant engineers, this would be their domain here. Whereas there's another group of people when it comes to energy that are not technical personnel that are used to using standard web browsers and things like that. Let's say a building owner, let's say a sustainability manager, a data center manager. They're not necessarily somebody who could make sense or from data from Wonderware or something like that. So for those folks who are used to more cloud applications and more standard non-technical personnel, they would be the kind of users who would use a cloud application, and they're interested in different type of data, financial data, for example. So that is basically what the OptoEMU sensor is. At the ground level here, we're connecting to devices either directly to power or to a gas meter, water meter, electric meter, to a power quality analyzer. We're bringing that data in, we're digitizing it, and we're serving it to different applications, either locally or in the cloud. So let's talk about those cloud applications. The two that we have, as we call it, connectors or APIs to, are Google Power Meter and Pulse Energy. Software as a service for cloud computing is very common in the commercial space, and the benefits of it are, of course, you do not have to host the software or the data. That is done with your provider. So there's a lot of applications. I don't know if some of you are familiar with things like Salesforce.com, for example. Those are kind of pioneers in cloud computing or software as a service. The goal with the OptoEMU sensor, again, was to make the data, the energy data, available to non-technical personnel who could very easily look at their building or their individual devices or sub-panels within their facility. And software as a service is a way to do that. Some examples of how this might be deployed. The first one is with the OptoEMU server. This is where you would consolidate data into the server, make that available to third-party applications through the SQL database. or use that to push it to the cloud when you have a distributed group of OptoEMU sensors. Where we are today is the individual OptoEMU sensors, and those can be deployed either within four walls, multiple buildings, multiple sites, it doesn't matter. At the ground level, of course, there's a variety of connections as we talked about. There's pulse inputs, there's direct CT inputs, and those can be deployed in multiple buildings, and that data is served up to the example here is the pulse software. Let's dive down to the most basic level of how we accomplish the connections. I think we've covered it a little bit, but I want to get into a little more specifics here. So if we start with a direct connection, this is where, let's say you had a compressor, any kind of high horsepower device, motor of any sort would make sense to look at that directly. So you would basically use a current transformer. We are supplying a relabel of a clamp-on type, which are very useful. So you use a current transformer, and you would also take the voltage in, and you would bring that into the OptoEMU sensor. And again, there we could do 3 single phases or 1 3-phase. We have the serial and Ethernet connections to talk to third-party devices, and for the building mains or a gas meter or a water meter, we accept pulsed outputs from these meters. And we could do up to 4 of those. There's 2 types of meters we've seen out there. They either have 2 outputs or a single output, and we can accept either type. So that kind of goes over the ground level connections of how we capture the data. And then of course that data we handle bringing that up to the cloud, which I will show you in a little more detail how that's accomplished. Let's just kind of finish on the technical details of a direct connection. So these are the 3 types, and I'm going to kind of go into each one in a little more detail. With a direct connection, the type of current transformers we support are the newer, smaller, less expensive ones. They have actually a voltage output. It's a 0.333 volts. So you have, of course, your primary current on the primary side, and on the secondary, instead of having a current on your secondary, you have a very small voltage, which is what facilitates them being smaller and less expensive. So very common out there, and again, we support the 0.333 volt CTs. So you would bring that signal as well as your voltage into the OptoEMU sensor. Now, what voltages can we handle? Some of you might be familiar with our AIPM modules or AIPM3, which could handle up to 220 volts. With the OptoEMU sensor, we've taken that to a higher voltage capability. So we can do, the electronics can handle up to 400 volts AC. So, for example, we could do as high as 600 volt systems. So 3-phase in the US at least, the common voltage is typically about 480 volts. So the way we handle up to 600 volts is we do a line to neutral measurement, and in a Y configuration, line to neutral at 600 volts, for example, is 347. Thus you see the 400 VAC. On a 480 volt system, line to neutral is 277. So you can see we can don't need a external potential transformer. You can go directly with up to 600 volts line to neutral. So now let's look at a utility meter. That's a very simple connection. Is you basically have either a 2-wire, 3-wire situation, single output or dual, and we take those directly into kind of DI inputs into the OptoEMU sensor. And the way that that's done, I'll get into a couple of screens where we show how the configurations is done, but your utility will tell you what one pulse represents as far as kilowatt hours, and we go ahead and scale that in the OptoEMU sensor configuration screens. Submeters, I was talking about, like Square D or SATEC or PowerLogic. Power quality analyzers, there's a fair amount of those out there, at least in the industrial world. So that's where we have the ability to talk Modbus or Ethernet to those devices as well. And finally, we realize that there's going to be, in larger buildings or companies, there most likely is a BAS system already in place, and thus we support BACnet and Modbus, and we can share data with those systems as well. Okay, configuration. An important point that I wanted to make is, for those of you familiar with Opto 22 and the PAC system, some of you out there who are integrators or machine builders, the OptoEMU system does have Opto 22 technology under the hood, so you can take the product and get into the code that's running in there and do additional things with it, which I'll touch on later. But the key point about this product is we really designed it as an appliance, that is for use by a non-technical person. So you don't need to do any kind of control programming or PLC programming or PAC programming to put this into operation. The way that the device is configured is through web-based configuration tools. So you put an IP address in it with a little utility that we have, you hit that IP address, and then similar to how you would configure, let's say, a router in your home, there's basically web screens to help you scale your pulses, scale your CT inputs, etc. So, for example, here this shows we're doing a pulse input, and here at Opto 22 we contacted our utility and they told us that one pulse represents 0.6 kilowatt hours, so we scaled it there. So again, we've tried to make it so it has more of a broad appeal to people not familiar with control systems. Now let's talk about connectors. If we go to, after we've, let's say, configured our CTs or our pulse, and we come over to this connectors, now we're trying to figure out what are we going to do with the data. We go to this connectors tab, and as I mentioned, we have two software as a service that we have developed the application program interfaces for built in. So all you do there basically is decide where you want the data to go. And that is done by a simple click of activate this device. And for Google Power Meter, you would have your Gmail account open and the data would start going there immediately. For Pulse Energy, you would go through, once you hit this button, you go through an authorization process where you decide which service you want to pay for, what package you want to get, and then it will come back with a license key, put that into the device, and it's automatic and you'll be showing data immediately. We've got these two to start. We are working on additional partnerships with other companies. We want to give our users a variety based on the application and the level of sophistication. So we're going to keep adding to that list of connectors. So I'm looking at my watch here, and I want to just briefly show these two software as a service products, and I think I have time if I go pretty quickly. So if you'll indulge me for a minute, I want to go ahead and show Google Power Meter. So I'm going to go ahead and log into, this is live data, by the way. We're looking at Opto's building. We've got an OptoEMU sensor deployed here. We've got it connected to our utility meter. We're getting pulses. We've scaled them. We're pushing data into both Google and Pulse. So I want to show that to you. We're actually got one at the mains, as well as we have three individual sensors getting powered directly from subpanels. So let me go ahead and log in. So this is Google Power Meter, and we're looking at live data, as you can see, for the Opto 22 building. And we're looking at electricity in kilowatt hours. Google Power Meter is a basic tool that will give you real-time and historical usage. We've got actually 4 OptoEMU sensors deployed in the building, one at the mains, one in a high voltage lab, which we're looking at now, and then a couple of other labs as well, some low voltage labs here at the facility. So you can see you can kind of get some cost data depending on your utilities cost structure. You can get a pretty good estimate. Some of the cost structures are pretty complicated, like the one is here, we're a time of use user, but you can get some cost data as well, some approximations, and basically get live data. Here's a historical usage screen as well. Looks like it's taking a minute to load. There it is. So that's Google Power Meter. So I'm going to go ahead now and pop over to Pulse Energy. Again, that's a Free tool from Google, one click of a button and a Gmail account, and you can be up and running with that. So let me come back to the next one. I want to show you Pulse Energy. If you want to take that to the next level, Pulse Energy is a paid service, but it's a pretty extensive tool. I'm going to go ahead and log on here. I'm not Ben Orchard, but it's Ben's account. And this also is live data from Opto 22's building. So let me go ahead and look at now. So what I've got showing here is I've actually got a temperature coming in as well as our building power. And it looks like we're right about at a break time. So we've got a pretty low power going on right now. Here is, there are 3 basic views in Pulse Energy geared toward, as they put it, the 3 different stakeholders in an organization. So this management screen would be for, let's say, facilities manager. Let me go ahead and look at now here. Let's look at by day. So the facilities manager is going to get power in kilowatts. You can do things like put in thresholds. Those thresholds can also be subscribed to trigger an email. I've got some thresholds set at some high peak values. You can do calculated points. For example, my orange line here is a predictive curve, or the typical curve is based on 2 variables, outside temperature and power in the building. So this is, again, the more technical screen, but very easy to use. Again, geared towards somebody who can use Crystal Reports or Excel or something like that. You basically, when you authorize your Pulse account, you'll immediately be seeing your building power, and then you can go ahead and do some calculated points from there by basically adding a new point and selecting from their drop downs. So that's the management screen. Reporting would be geared toward, let's say, the business owner, or maybe the sustainability manager, the accounting people. I've got a couple of reports I've created. They took me all of about 30 seconds to do. Again, this is designed for kind of business people rather than somebody who is expert PLC or PAC programmer. So I've created a report for kilowatt hours per day, very simple report. I've done a subscribe where every month this is sent out to me. I'm going to show you another report here. Here's one that's a greenhouse gas emissions footprint. So built into Pulse, there are algorithms and calculations for things like greenhouse gas emissions. A very important report is dollars or power cost per day, and so I've got one built for that as well. So let's let that load. Here's our chart for power cost per day. So again, management is more for the facilities people, reporting for kind of the people who pay the bills or people who are accountable for energy. The final one is kind of interesting. This is called dashboard, and this is what's called occupant engagement. So the dashboard is kind of your PR screen. So let's say, for example, your company or your client's company has a flat screen TV in the lobby or maybe in the lunch rooms or the break rooms, and they want to kind of promote their sustainability initiatives or their energy consumption reduction initiatives. This dashboard is geared toward that. You could do multiple buildings, you could do contests between buildings, and you can customize this. I'm showing our real-time electricity, as well as I have put in some green features, things that Opto 22 is doing. So as far as you or your client could do this as well. So this again is the occupant engagement, trying to get people involved in the programs, get them to be energy aware, get them to take some action as far as their individual contribution to energy reduction. So those are the 3 screens of Pulse Energy. I just wanted to give you an idea what those were about. I won't take too much more time on those, so let me pop back to the presentation here. Something I want to emphasize is that while this product is new, it is built on Opto 22 technology. So again, the new part of it is we want to open up the door to a new audience, somebody who is interested in energy visibility, energy awareness, but doesn't necessarily have the technical skills to implement a typical automation system. With regard to that, for those of you that are Opto 22 users or system integrators, keep in mind that under the hood is a PAC R2. So if your client or if you as a user decide after let's say some period of time where you've studied your energy usage at your building and on your devices and in your various areas of the plant and made some changes, running things, staging things, having processes run differently. If you want to get into control, this of course is fully expandable and compatible with a PAC control system. So you could basically use the OptoEMU sensor as an I/O unit off a SNAP PAC controller, and then you could get into control, automated control, demand response, etc. So it is fully compatible. Just to give you an example, you know, the measurement technology inside the device is based on the AIPM module that we've been selling with PAC, and you know, we have over 1,000 of those in the field. So while it's a new device, it's built on existing trusted technology, and we do have some expertise on the measurement of energy through the AIPM module. I wanted to kind of go off of the product now and just kind of close with a few thoughts on the benefits of monitoring. For those of you who are on, I'm not sure if you caught a webinar we did about a month ago. We had our consultant Bill Holmes on, who's got about 35, maybe 40 years of energy experience. I see he's on today. But we talked about the benefits of energy monitoring, and he shared real-world case studies from his experiences with customers. And so I won't go into too much detail. That has been recorded and is available for you to view if you want to on Opto's website. But the benefits of monitoring, basically what we're going after with this product is there's a tremendous amount that one can do after they take the simple step of being able to visualize their energy usage for a building, more granular within inside the building. He found in his studies, and he shares those in those case studies, things like equipment that wasn't operating as it was expected to, equipment that was degrading that no one was aware of, behavioral changes, things running simultaneously when they could be staged. So a lot of what we're trying to go after is behavioral change, operational change. And the reason I say that is if you like what you've seen and you want to champion this to your company, or if you're a service provider or an integrator and you want to push this to one of your clients, the moment you get into control, we're all from the automation world, but once you do that, all that baggage that comes along with automation systems is going to come with you. But if you position this product, or you think of it as something just to gather data, where you can realize tremendous savings from behavioral change, I think it's going to be easier going for you. And there's a lot that can be done. So the bottom line is, you know, what we're hoping to do with this product, and hoping the use that you'll find for it, is that in the same way that building owners, plant operators control costs on every aspect of their operation, it's not so common that that's done for the cost of energy right now. And if you look at the cost, let's say, associated with a machine or process, equipment, parts, raw materials, labor, I think what we've seen, and Bill could attest to this, is if you add all those up together, they still are dwarfed by what the cost of electricity is to run that process or machine. So that basically represents the largest opportunity to cut costs out of a process, operation, machine, or company. Once again, the first step to doing any of that is an easy way to visualize the energy usage, and that's what the OptoEMU sensor is all about. So I know I talked pretty fast there, but hopefully that made sense to you. Hopefully the product looks interesting to you. I will now go ahead and open it up for questions, and I see we have received a few questions, so let me go ahead and get to those now. Give me 1 second. I'm going to go ahead and read those, and I don't know if Ben Orchard is on the line. Ben, if you're there, can you say hello? I don't see that he's on.
Yeah, hello everyone. How are we doing?
Great, thanks, Ben. Just in case I need you, I'm going to take a shot at this first question here. And it says, do Google and Pulse permit water and gas management also? Great question. And I will say that the answer to that is Google does energy only from electricity, whereas Pulse, it's wide open. Ben, anything to add to that?
No, I think you've hit it well. Pulse can take multiple parameters, whether it's water or gas. The EMU sensor can be configured for many different units, megajoules, kilojoules. We've got gallons per hour, litres per second, cubic feet, cubic meters. There's lots of options in the drop-down web configuration, and any of those can be sent up to Pulse. Google, our communications with Google, they're focused on energy at this stage, but they're not ignoring further markets in the future.
Thank you, Ben. The next question is a great one. Can EMU tell me when I'm about to hit my PF or peak demand? I'm not sure what PF stands for, but I know what peak demand is because we go through that here at Opto 22. So the answer is yes. Now when we say the EMU is collecting data and it's putting data into a software package. So yes, in the sense that Pulse Energy can let you know when you're hitting your peak demand. You saw, probably very briefly, I flashed through it. I had the management screen up for Pulse where I was showing the real-time energy data, and I had some thresholds set, and that's what I've done there. Is I set it at I think 550 kilowatts. I get a notification that I hit that value. I don't know how your utility works, but ours, they don't set a threshold. It's basically whatever your peak demand was for the month, they hit that value with the tariff. So if we hit, let's say, 650, they're going to multiply that by $16 or whatever our tariff is. But yes, you can set thresholds, and you can trigger an email to make you aware that you're hitting that, or if you want to be below that before you hit it, you can do that as well. Pulse, I scratched the surface. It's actually pretty powerful software. And so you can look at pulseenergy.com on your own and take a look at more of what that does. Or contact me and we could do a personal demo for you with the Pulse folks. Next question. It's a long one, so bear with me while I read it. I'm going to do my best here. I'm both an Opto integrator and a solar/wind installer. My question is, when I go to a commercial client and look at their bills, you will see kilowatt hours usage, but what kills them is the demand charge in kilowatts. Can your device tell the difference? I'm going to go on. Oh, let's take it modular. So let's take that first part. So again, the device is collecting kilowatts. We're sending kilowatts into, let's say, for example, Pulse software. And there again, you can, as far as differentiating, I know our bill as well is broken into a couple of parts. One is your usage, and one is your demand, which is actually your peak times your tariff. So you can definitely look at your kilowatts, and if you know your high value is your demand, but we're tracking kilowatt hours as well as kilowatts. Can it differentiate? I don't know that it can. Ben, you got something that you can add to that?
I'm sorry, Arun, I'm struggling following the question.
Yeah, it's basically differentiating between the demand and the usage. So that when you get a bill, they basically say your demand or your peak value was, let's say, 650 kilowatts. Your usage was blah blah kilowatt hours, and they charge you separately for each of those. When we monitor, we're monitoring kilowatts, kilowatt hours. So I don't know if yeah.
I'm thinking the answer is just a software answer. I mean, we're getting the data. The data is there. I'm just trying to think where the analysis should be done, because ultimately I think, yeah, we should be able to coax the system to differentiate between the two, but I'm just trying to figure where that would be best done, whether it would be done in the EMU or at the Google Pulse or perhaps some other future connector.
Yeah. Chris, that's a good question.
Yeah,
and
we're going to mull that one around.
yeah, let's mull that one around. We'll maybe you could email me or I can email you and we could talk a little bit more about it. Okay, next one. Okay, PF is power factor. Thank you. So, speaking of which, power factor. At this time, the OptoEMU sensor sends back data in kilowatts. We don't break out, power, true power separately to be able to get power factor. Though that can be done, as you probably know, in an AIPM module. The next question is...
And sorry, Arun, just to be super clear, the information is in there, in the EMU, but we just haven't revealed it at this stage. If you're an integrator, you can certainly reach in and calculate that or grab that data. So it's not like the EMU can't do power factor, it can, it's just that at this stage in version 1 we haven't exposed it, but we're getting interest on it, and your question is noted, and certainly we'll forward it through to the engineers about exposing power factor.
Thank you, Ben. Yeah, so keep in mind, if you're an Opto programmer and you want to get underneath the hood, it's a PAC strategy running in there, so you can get at it and do what you will with it. Okay, the next question. Will Opto current software PAC project be updated to also do this type of pushing and managing data to the cloud? More efficient, elegant management for Opto PAC. Go ahead.
I'd love to answer that one.
Yeah, go ahead.
Yes. That's it. Yes. Make sure you subscribe to Opto News. We got some really exciting stuff in the works. Obviously can't say too much about it, but yeah, there's some really cool stuff coming for pushing information around to different connectors over the web.
Okay, it looks like that is the last question. We're right about on time. We're a minute before we end, so I wanted to thank everybody for coming on. Hopefully it was informative. We'd love to hear from you. You can contact me if you have any follow-up questions or you want more information, you want to see more detail on any aspect of this. My email is on the Opto 22 website under Corporate Contacts. I'm Arun Sinha, and I will kind of start from there and get you engaged. So thank you very much, everybody, for coming on, and we appreciate you taking the time, and have a great rest of the day and weekend. Thank you.